Cool. Good day, everyone. Good evening. End of a long Wednesday. So, welcome to DevUG, November edition. We just have a couple announcements to make before we get into the talks that we have today. So, number one, DevConf tickets are still on sale. We even have early bird tickets still available. So if you guys are keen, you should go grab those. DevConf is a really awesome event. I go every year. Totally. And then the second point that we have is Geek of the Year that's happening. It's happening on the 8th of December this year. There will be some prizes. It's just all around fun. It'll definitely be remote again this year, as it was last year. So we are really looking forward to seeing as many people as possible joining that. Did I mention there's prizes? Yeah, so just as a heads up, there are prizes. Cool. So our talks today are the first one. It will be Ezra. He's going to, so it's a bit, we're swapping it around based on what's on the meetup. So the first one we're going to be doing is getting through the dark times, load shedding DIY, and this will be by Ezra. He's a software engineer by day, many things by night. So he likes doing things in security, electricity, amateur trading, all sorts of stuff. You can ask him that in some questions later. But we're looking forward to see what he has to tell us about his load shedding DIY. After Ezra talks, we will have MG speaking to us about some kaggle and some online competitions with regards to machine learning and AI. So we're really looking forward to that. Take it away, Ezra.
Let me unmute myself first. Yeah, thanks everybody for coming through. I am just basically going to be sharing what I did to try and get through load shedding. Long and short of it, let me first start screen sharing. There we go. Everybody sees that? A thumbs up from anyone, since there are no faces?
Yes, it's perfect.
Yeah, well, you have to show your lovely face, come on. Can't just have a booming voice. Okay, so, okay, thank you. Great, more people. Right, so starting off over here, I literally just put together a little box. I wanted to get a bit of code into this, which I didn't get to, because obviously that's the last thing you do after you stop almost electrocuting yourself or blowing fuses and other devices. But this is just what I did to try and get through load shedding. Basically, when lockdown started off, Intellect decided to sponsor us with a little bit of money in order to get some sort of UPS going so that we can obviously work from home throughout load shedding as well. And I decided to add a little bit more of myself and like build this whole UPS or backup power for myself. And this is my journey. Firstly, I'll start with the boring stuff. Let's go. There we go. So I had to figure out how much power I needed. I needed a TV, 180 watts for that, laptop 50 watts, and my second screen, which I definitely need while working from home. Otherwise, I'm a quarter as productive as I usually am, which is pretty low. So I calculated that my total power would be 270 watts over 2.5 hours, which is basically 675, that's watt hours. Got myself two 50 amp batteries. Didn't go for normal car batteries because obviously you cycle those a few times and they did. 12 volts and ended up with 1,200 watt hours basically, which would kind of get me through that time, as long as load shedding ended at 2.5 hours and not at 4 or 5 hours as it does in Pretoria and Joburg here. Anyway, enough of that boring stuff. There are a whole bunch of stuff about losing power and the actual power output that you get and length of wires, which I'm not going to go into. You can ask about that at the end if you want to know more. Yeah, so when I started off, I had this. I think this looks quite beautiful. It's on wheels, old cupboard board that I put together, drilled in. This is my little inverter over here and my two batteries next to each other. You can see I mentioned shoddy wiring. There we go, nice shoddy wiring. Just stuff it into a multi-plug, get it going. And you'll see this over here, which is, well, there. Initially, when I started making use of this system, I told my wife, listen, if you would like to make use of this, all you have to do is turn that one switch and it will go on and you can use it, no problems, you'll be happy. That didn't quite go very well for me because obviously, as you can see, wires everywhere, very unsafe. I myself was not too sure about this because my words were, you can turn it on, but please don't move it because something might come loose, you might start a fire, something's going to fall out. On I went, back to the drawing board. I got myself one of these little boxes. I found out later they're called ammo boxes. Not ammo because like a battery's like explosions, but ammo because usually used to transport ammo. They're also stackable, which was nice because the plan was to be able to add more power as you go along. Did the whole design, drew it up, got my confidence from my wife, told her this is going to be it. You won't have to worry about what you press, how you do it. It will work. You can wheel it over without things falling off. It's enclosed, safe, everything. And great, all of that happened. Ended up with this. This is current setup. Over here on the side, you'll see there's a bit of some text showing you how full the battery is. The inverter obviously starts beeping the moment things go wrong. And here, you'll see these little red things are covering these plugs. I think these are Brad Harrison or Anderson Anderson connections. But it allows you to quickly connect and disconnect devices. So my ultimate plan was to have this hot pluggable. You can plug in extra battery power when you need it, charge it quite easily as well. Left side is for charging. Plug my charger in over there. This is for solar. I've actually got a solar charge controller. Unfortunately, work in progress still. Don't have any, I don't know if you can see my screen yet, but load shedding just kicked in. I'll just switch over. I'll be 1 second. What do they call this? A live? And there we go. Got our power going. I think you heard that revving up. Can you still see my screen? Currently load shedding, but there is light. Oh yes. I guess this is a good proof of concept. I'm not sure if you heard that fan going on. That's kind of what happens when load shedding kicks in. My laptop's plugged in, light, screen. I think the TV is also probably connected to the system as well, so it starts going pretty crazy. It's not using much power though. But anyway, this is what's plugged in right now. And if you remember this little switch, I put a nice big thing saying inverter over here so that there's no wondering if it's the left, the right, my left, your right that you have to switch on. Solar will go this side. I think this one that's unlabeled, very bad of me, is actually where the charger goes in, so you can turn everything on and off selectively. Bad form using a light switch, or basically this whole socket for the light, but it works quite well. I can turn things on and off as I see fit, and I'm pretty happy. My wife's pretty happy. She hasn't called me out from work to come and switch it on for her since this has happened. Let me just see what's in the chats. Live demo, yes, it was all planned. I'm sorry for load shedding today. I saw somebody put in the chat, live demo, yes. My fault that load shedding happened, perfectly timed. It's also why I wanted to go first. Okay, then I kept this shoddy electrical work. Over here I've got a little switch. So with this, for example, when I am away from home and I'd like to have things switching on and off, or might want to have the fridge or something going during load shedding, or connect something up, switch lights on and off. We've all watched Home Alone. You can make a pretty convincing act at people being at home by turning random lights on and off. So this little device allows me to turn things on and off. It's kind of my mind's power, connected to Google Home. I think I'd actually be able to turn everything off right now, but I don't want to do that. Otherwise, I can't see what I'm presenting. And over here, you'll see that little, what's that, Brad Harrison connector. You can plug things in and out. So color-coded so that you can never plug an inverter into a place that it shouldn't go and possibly end up using weird fuses or the wrong power usage, like going through the connection. And yeah, that's pretty much it. Oh, and obviously, nice wheels. I got bigger wheels because I noticed after a little while my little tiny wheels were starting to wear off, and it was kind of falling apart on that little board that I put together. But this ammo box is pretty solid. And I think the last thing that I'd want to do with this, two things to integrate with. These little bad boys. Yunlong lithium titanate batteries, 950 each. To get the setup that I have, I think each one of these is 40 amps. I need to get 5, so that's 5,000 times 2 to get the same amount of power usage that I've got. Only difference is I think I get about 500 charges out of my current battery, complete drains. This one should give about 10,000 of those. And over here, the Battery Ninja. Monitoring your battery's health is kind of important. Don't want them to explode, don't want them to go all weird. You don't want them to die within like 2-3 months. I've been using mine for a year on and off for load shedding, and I haven't noticed any degradation, but this will actually tell you what to do. It sends you a message on Telegram when your battery's running low, if there are any problems, things like that. Open source. This was actually a project done by one of the guys at Intellect. Obviously, Intellect gave them some money to go and do a project. They put this together at a very low cost and monitors your battery pretty well. I'm not going to demo that though. And yes, I think that's about 10 minutes through this. Are there any questions? You can reach me at ezra.jivan@gmail.com, also at intellect.com, same. Twitter handle at Ezra Jivan, and please visit intellect.co.za. Let me do some advertising. Yeah, any questions? You can unmute yourselves if you want.
I think we might need to allow that. Let's quickly do that.
Okay, if Joshua allows you to, you can unmute yourself.
Cool. You guys should be able to unmute.
Let me see if there are any questions over here.
There is one from...
Okay, so what were you going to say, the how much did it cost question?
Yeah, I was about to read out the question for you.
Okay, cool. How much would it cost for you to do the same, or how much did it cost me to do this? Because those are two different questions.
That's funny. I suppose both, because the one will be much more realistic, you know, and I'm very interested in this. It looks phenomenal, but it also looks expensive. But I don't know. So yeah.
Okay, so batteries, those two little batteries, like I said, they can run I've got a 65-inch TV that's pulling, I think it pulls about 170, 180 watts. 55-inch TVs will pull almost half of that, so especially if you have one of the newer ones, and you'll be able to get away with like a 50 amp 12 volt single 12 volt battery with that. Only problem with going 12 volt and not linking them up is that it costs you more in the long run because you drain deeper and your battery's way quicker. But each battery, 12 volt 50 amps, was 1,300, I think. It's probably more now. That was 2,600. The inverter cost me 1,500. I'm terrible with math, so somebody needs to count this for me. So that's 2,600 plus 1.5. What else do we have here? That little switch thingy cost me less than $50. Wiring, so yeah, don't get swindled with wiring. If you're not going to use very much power and you have a small inverter, go for something small. So I went for a 3,000 watt inverter, which will never be used by me. My batteries can't even handle that much power because they'll start like, yeah, they won't last very long. But you can get an inverter for like 1,000 watt inverter. You won't be able to run your microwave or possibly your fridge from it, but it will work for basics. What else? Wires, yes. You can get away with 4 meters of wire, which is $40 per meter. So the black and the red, quite comfortably. Anybody got a tally? 1.3 plus 1.5 plus.
I've got 42 for 120 on the wiring. I've got 4270 on the total. Less than 5,000. That's not bad.
Less than 5,000. And the little plugs that I've got as well. So those were $50 each, but I found places where you get them for like a lot less. But those are kind of high amp plugs, so you can quick plug and unplug things. But if you want something static, you don't need that at all. Oh, and the battery box, $200. Oh, the ammo box, as it is. So it's just over $5,000. Things that were pricey would probably be, let's see if I can find it. So you know about the dodgy wiring. You can take yourself a clamp or a what do you call those little tools? I do not have one to show you, but you can just basically take something to clamp the batteries together, or hopefully this will show. I got myself one of these, which literally will squeeze it closed. So this is the safe way. It's a hydraulic, what's it? Can't remember. It's a lug tool. And that basically gets the little connections to your battery, gets your wire and the lug connected properly, so that kind of won't come out anytime soon. I also got myself a proper cutter and stuff, but like this is over a few years, so almost 2 years now. I guess it would cost 7,000 in total with wastage. So I bought one type of wire that's too big, didn't need it, still have like meters of the stuff. Can probably wire my house with that eventually. That cost way too much. And yeah. Any other questions? I've got other fun things I'm doing, like I'm playing with these, I'm not sure if you'll see these, supercapacitors, which are very, nope, no. Thank you, Zoo. Almost. Oh, it's almost like a really big battery, but very low power usage, but it's got a big burst of power. So for example, when I was talking about things that won't work with these batteries, a printer, for example, it tries to pull about 1,000 watts on startup, which kind of deteriorates your batteries. Putting a bunch of those supercapacitors in front of it will allow for the big power. I'm not building shock machines. I've seen that. It explodes. Earvolt's comment. So it takes the biggest drain of the power so that your batteries don't take that. And then they'll technically last longer when you have those big spikes of power when you plug things in. But that's all future. So in all likelihood, I'll build one of these with supercapacitors, plug it in, and like just make sure that that takes most of the strain before the batteries do. Just disclaimer, I am not an electrician. I haven't started any fires yet, but this is fairly safe with all the switches off. With the switches on, I guess I wired it better this time. I used proper wiring, clamped them properly, got ferrules which kind of allow you to put wiring in properly without too much play, and the chance of them actually coming loose as well. So yeah. Any other questions? Nobody wants to know when I'm going to start selling these, making money from it. Nobody wants to buy one. Nope. With solar. I got myself one of these. So I've done the wiring for the little charge controller. I must just get some panels, which will probably cost, I think, don't need too many panels for this, probably like 2,000, 2,500 should be good enough. And then it can kind of be self-sustaining. I can take my entire, this is my office, off the grid and just use solar all day, batteries. Yeah, solar panels. I think what I mentioned was probably a 200 watt, which would be fine for charging things up. I mean, 50 watts plus less than 100 watts is what I'm using with my screen, laptop, phone. Yeah, Errol just asked a questioning the price of my panels. And yes, I do have some contacts in China that can get them for a low cost too. Batteries too, but I'm not sure if I should take those offers yet. Okay, any other questions? All right, thanks. And if you want, you can email me still, ezra.jivan@gmail.com or intellect.co.za, and reach out on Twitter. You'll find me quite easily. Schematics. I do have some. Sure, I'll do a blog post about it. I'll put it all together, put together some of the schematics, wiring size as well, recommendations too. I don't want to be famous, Errol. I want to be infamous. But I'll deal with famous. Okay. I'm more famous. Okay, thanks. I guess, Joshua, you can take it away if you want to continue going on to our next speaker, or should we just roll with it, MG?
Oh, thanks, Ezra. No, that was great. Our next speaker, as Ezra has pointed out, is MG. He's a mathematician that builds models and writes quantitative software and mobile apps for a living. He has built lots of different things for lots of different people, like Eskom, Telkom, National Treasury, the Reserve Bank, and so on, as well as algorithmic trading models for the Dutch bank, it seems. Yeah, so he's going to be talking to us a bit about AI competitions and some pitfalls and things that has happened there. MG, would you like to take it away?
Okay, yes, thanks. Let me just share my screen. I'll start my video. If I start breaking up, just signal me and I'll switch off my video. I think that interferes with I just switch it off.
No problem, we'll do.
Okay, thanks. Let me get the share going. Okay, there we go. Okay, guys, so I want to talk to you about this, about how you can sharpen your skills with online competitions. And then there's also this little bit of a clickbait. Secrets, kaggle, grandmasters don't want you to know. So if you remember that, ask me the questions and I'll give you some. Of those. Okay? I've got this little business called Fera Solutions. Sorry, and under the logo, we've got these three phrases, mathematics, models, business solutions. That's really what I do. That's what I've been doing for years. Use mathematics to build models, and then from those models implement business solutions. So at one of the kids' birthday parties, we a bunch of men standing around a fire, and somebody asked me, "So what do you do?" I said, "Well, I do modeling." He looks at me and says, "Oh, standards gone down, right?" So, but that's what I do for a living. So anyway, in 2004, I was preparing these market intelligence reports for a bank, and they asked me, can I build them some trading models? And I said, sure thing. That's right. In this space, I'll build them some trading models. And so I started work on this problem here in green, and the problem being construct something that will do successful short-term directional trading, that will execute successful short-term trading, directional trading strategies. That's the problem. The solution sits in here. And I started. Initially, I thought it's going to be a quick thing. I had so many techniques at my disposal: econometric models, time series models, technical analysis. I even used some machine learning approaches like k-means and trees and stuff like that. But none of those could really bite into this problem. And after a couple of months, really in frustration, I started work on neural networks. And they gave me a little bit of an edge. They never really solved the problem, but they at least made some headway into finding a solution. And then for the next couple of years, until about 2011, I built neural networks for them. And my pay was linked to the success of the models. So you know, I might have lost some hair, but that's what I did. Since then, I've mostly been developing software for other people who build models. But there was this huge explosion in AI in recent years. I mean, it's everywhere. You can't switch on a screen and you see something about AI and deep learning and stuff like that. And I enjoyed that. I actually enjoy doing that. So I wanted to get back into it a bit, and I thought maybe I should go into Kaggle. So in December last year, I joined Kaggle. I immediately didn't like it, And now, at the moment, I'm sort of migrating there. I'm competing more and more on Kaggle. So there's nothing wrong with Kaggle. But Kaggle was too clean. It was too, babying of a platform. So you go into Kaggle, and this is my experience. Like you get something like this. Do you want to solve puzzles where the answer is an animal, or do you want to solve puzzles where the answer is a city? So it's like that defeats the point. That's not the real world. Now, and then I got busy again. Then in April, I had a contact that should have started 15 April. And eventually that one was postponed till 1st of May. So all of a sudden, I've got this big gap in my calendar. And GTC is happening. This NVIDIA conference that is huge. I mean, this is amazing. And I attended a lot of this session. I mean, I came back from that so fired up. I just wanted to do something with all the fancy AI and all the developments I saw there. I attended a lot of sessions. One of the sessions I attended was this one called AI in Africa. And there they discussed Zindi, a company in Cape Town, and they host these AI competitions. And at the time, I had a computer or two lying around. I had some time on hand, so I hopped over and I basically picked the top competition and entered that. And that competition was this one, the Lacuna competition, as it's known. Now, this competition is phenomenally tough. It was like from the word go, it's sort of impossible. Some of the contestants were complaining about it being unsolvable. It was my experience to really make a headway with this was really difficult. And you would ask questions to Zindi or the host, and you would wait weeks before you got a reply, and I loved that, because that's how it goes in the real world. You talk to a client and all the data is clean and ready, and you just need to come in and solve the problem. And when you arrive, the data is dirty, the problem isn't well formulated, and you have to solve all these real world problems and that's really what I wanted to do. I wanted to get that sort of real world experience. And so I competed in this. I competed actively. And in this competition, a measurement has been taken, that black dot with a circle around it. That measurement is wrong. The correct one is this red one, which is in the middle of this substance field. The guy is using this field to provide a living for himself, but whoever took the measurement took it from the nearby building or the nearby road. And you have to correct that and find the center of the field. Now, this is how it's put to you in these high resolution photos, but the photos you get are much lower quality. And here you can see a model that I tried trying to segment that photo, and it's nearly impossible to solve this problem. So as with the trading models, I tried so many different techniques. Now, these are all more modern techniques, things I picked up in the conference or that I'm aware of that are recent developments. And none of them really bit into the problem except for these networks. And so I went along with that for a while. But the experience was amazing. It was really I found it really sharpening my skills and exposing me to a lot of the more decent techniques. Okay, so let me go on a bit of a diversion here with tangent. What is a data scientist? You know, it's a hot topic at the moment, and so how do you define a data scientist? Now I've got a kid, my eldest kid actually. She can play piano. You know, man, she can make you cry. She can really play it well, and by the time she hits matric, as parents, we sort of concerned, you know, should we fork out all the money and send her to London for training? And even if she's hugely successful, will she be able to pay the bills? You know, as a pianist, can you bring home the bacon? And the first skill you need as a data scientist is math and stats. That's sort of the basic foundation. And when I grew up, math and stats was like art or like playing the piano. You know, it's beautiful and wonderful, and you can study it. But does it pay the bills? You know, your parents forever wonder. I think my parents are still concerned, but let's leave that at that. So that's one of the foundation skills that makes a data scientist. Then the other one is computer science. You need to be able to program, right? And that's why I feel so at home presenting it here, because so many of the techniques and technologies and things that you will find in this space are things I presume the audience, you know, that you do on a day-to-day basis. You need to be able to implement a model cleanly. You know, if you can do a nice, clean, sharp implementation, I think even if the model isn't that sharp, you're in a much better place than somebody maybe with a better model. So that's, to me, that's almost the biggest circle of the bunch. And then you need some domain knowledge, which in my case would be economics and stuff like that. It could be security, it could be agriculture, you know, it could be many other things. And those three combine, and they give you a data scientist, right? So I showed this picture to my wife once. I said to her, look at this. She looks at it, she said, oh, but that's you. And I say, yes, that's me. That's an identity crisis. And to some extent, that's what it is. You know, I still wonder. I'm a bit advanced at the moment, and I still wonder, should I go into computer programming? So my business, my plan B always is, honey, if it doesn't work, I can always go and code Java at the bank or something, you know. But where do you gravitate to? And the nice thing at the moment is that there's this space in the middle somewhere where I feel at least right at the moment, that's this data scientist place where you sort of intersect all of these things. From a functional perspective, you know, I think data science is a support function, supports business, and I think it's closer to business than it is to IT. There's some people that think the data science function, if you want, should sit with IT. I think it's closer to business, if not inside business, sort of give strategic support to business. That's just from a functional perspective. Okay, so let's go back to the competition. So let's say you compete. What should you do to compete successfully? And first of all, you know, you should put away some time. It's not something, you're not going to sit down in one evening and read through the competition and put together the solution and change the world. It doesn't work like that. You have to put in hours. It takes you weeks just to understand what they ask, and then a couple of weeks to code up something that maybe works. And so you need to have a computer, you need to have some resources, you know, to do that with, and you need to put in the time. What not to do? Well, you shouldn't do it sloppily. You know, you're not going to sit and in one sitting finish this. So even though it's maybe 2 or 3 months, you need to code properly and document your code with comments and stuff like that. So again, I feel I'm speaking to my people here, you know, because you are, all of you are programmers, right? And the same things you need to do as a programmer, like write the code properly, document it, even if it's just for yourself. The same things apply here, right? Then competing in a team, that has changed me, and that was phenomenal. And I would recommend that you compete in a team at the top of a hat. Now I can still remember the first time there was this guy. He's a kaggle grandmaster, by the way, and he asked me, let's form a team. Let's compete in a team, and I was so excited. You know, I created this website and I put bullets there of who's going to do what, and timelines and targets, and how we're going to communicate and deliver. And I shared all of this with them. And so we have our first Zoom call. And I said to him, did you see my website? And what do you think of all my bullets and stuff? And this guy in extremely broken English, he says to me, too many words, you know. And later on, I realized he didn't even read it, you know. And today I look back at that, I'm like, MG, grow up, you know, it doesn't work like that. It's amazing, you know, it's amazing to compete in a team, because you compete from all over the world, different time zones, different languages, different religions, different races and time zones. And somehow, you know, there's no leader per se. You have a team leader and he might arbitrate some stuff, but with all of this chaos, out of this, you build these incredibly complex models that solve these really hard problems. And that is phenomenal. It's a phenomenal experience to do that. So, okay, if you want to host a competition, what should you do? Well, a big prize always attracts people. The bigger the prize money, the more people will enter it, the more people will try and solve the problem. That always creates a bit of buzz around it. And what not to do? I think a mistake would be to treat a competition as sort of a IP factory. We're just going to drop a problem and get back the IP that you need to solve. You should interact as well. You should walk on the journey with the contestants. I think then you'll have most benefit from it. Zindi, I've competed a lot on Zindi. Zindi is located in Cape Town, as I mentioned, and you know, I think we should support them. We should support them by competing on the platform or by hosting challenges on the platform. They are good people, local people, you know. So they also try to develop people's careers and use data to provide solutions to the challenges we face on the continent. So that's what Zindi's about. Let me go to the next one. Okay, some of the concepts you'll run into as you compete. The first is play. So if I compete tonight, I'll say to my family, I'm going to play, or I'll say to my friends, I'm playing tonight. That means you're busy competing. Comp is a competition, a sub is a submission. Typically a CSV file that you upload to a server, then the server will score you based on that submission. Timeline of the typical competition is 3 months. And about a week before the end, you can't form a new team or into the competition. So there's some deadlines and so on. Each competition has rules you should take into account. Then there's this thing called kernels, the kaggle kernel. That's like a canned solution, and that changes the game a bit, you know, because you can have a problem that you on Kaggle go and find and download the perfect solution for, even though you don't understand the problem, you don't understand the techniques or anything like that. It's very easy to get a canned algorithm that will solve the problem for you. And I mean, if you really compete at a high level, you probably will need to use a few kernels. But of course, that sort of what's the word? It weakens it for me a bit. That won't sharpen your skills. That will sharpen your integration skills. So I try not to use kernels. I do the stuff from the ground up, and I try to implement techniques I only read about and stuff like that. So that's kernels. In the leaderboard, as you compete, there's a leaderboard that keeps score of where you are. And the leaderboard works like this. To compete, there's a public leaderboard. That's made up of about 20% of the total sample that you are scored against. So let's say you need to identify or classify some cancer, let's say. You will have 20% of the total sample available, and that will, you don't get it, but when you submit your answer, 20% will be used to score your answer. And then when the competition closes, the rest is used. The full 100% of the sample is used, and that determines your final standing. And this one is called the public, and this one's called the private leaderboard. And there's oftentimes a shakeup, especially in a big or difficult competition. You have a big shakeup, like like here. So for example, if you look at this, there's the old or the public leaderboard position. And for example, this guy, that guy there, he was number, let's say 3,200 or something. And then when they scored the full sample, he became number one. I mean, on this axis, he's number one or close to number one. So there you have a big shakeup. Likewise, that guy, he was number one initially, and when he was scored on the full sample, he dropped to number 2,000 and something. So there you see a shakeup, and that also happens. Something else that you will run into is leakage, called leakage. So oftentimes there's leakage in the competition. That means that some data that you shouldn't have became part of the package that you got as a contest. So you think these things are squeaky clean and that all these mean data sciencey people never make these kind of mistakes. But there's my competition experience. I've since competed in 10 competitions, and 5 of them had some kind of a leak in it. And this goes across Kaggle and Zindi, right? And you know, it's a funny thing because, for example, on Kaggle where there was a leakage, what the hosts did is they said, okay, we're going to add random noise to the solution just to prevent anybody from exploiting the leak. And there was a huge outcry about that, and then they took the noise away. So the moment leakage enters, although it can give you an advantage if you discover the leakage, typically it means the rules are going to change or something funny is going to happen in the competition. And so you sort of have this unpredictable element as well to deal with. Okay, what are the technologies that you need if you want to compete? And again, this is why I enjoy presenting it here, because I call these developer familiar tools. You know, Python is really big in this space, and thanks Intellect, I use PyCharm, of course, which are one of these tools. R is also used a lot in the other mathy stuff. Jupyter notebooks are really big in this space, which is sort of an interactive Python type environment where you can code and interactively see all the results and also submit that to a host to use. The cloud is big. You know, you do your calculations typically in the cloud on some hosted GPU somewhere. And that's a big change. You know, I've been in this space for a long time, and for the first time now, the cloud, the computers available to me for free in the cloud are more powerful than the ones I've got. Slack, Discord, you know, your normal communication use. Okay, and that's it. Let me look at the time. I've got 1 or 2 more slides that I'm quickly going to rush through since there's a little bit of extra time. So let me quickly take you through these extra slides. There's really been an explosion in techniques, and to some extent, this space is the science of decision making. You know, there's just like in programming, there's a heap of decisions. Which model am I going to use? How am I going to transform the inputs? You know, am I going to average it, and what kind of average I'm going to use? So here you see, for example, am I going to use an autoencoder, which is a model that will take something in and crunch it. I mean, let's say that's 256 by 256, so it's 65,000 something values that you get input here, and you squash that into 3 or 4 values. And if the network manage to learn faces, it will reconstruct that image for you. So like that image, that's a computer generated. So that thing's an autoencoder. There you see a typical network. In 2005, that's what a neural network looked like. Input layer, maybe 1 or 2 hidden layers, output layer. Nowadays, it looks like this. So there's a neural network that you'd use to process images with. This one is a transformer. You use that for natural language processing. This is reinforcement learning. That's the one that will play games. You know, Dota, that thing I think can play a mean game of Dota. There's an autoencoder that you can use to detect network. So things have really advanced quite a bit in recent times. then this, I'm going to skip most of this just to show you some let's say appreciation of the score. What's in the score? What if you come to me with a good score, does that mean you're better than the other contestants? You know, and I would argue, you know, you don't need to really pay that much attention to the score. Compete, you know, give your best and play to win, but the score almost irrelevant. This is that lacuna competition. This is the first guy on the private leaderboard. This is a type of error. And so the smaller the better. The top guy got 0.233, right? Number 88, these are all the serious contestants. The rest were, you can throw them away. You can see they weren't serious. This guy got 0.25. The difference here is about 0.02, right? Now remember, this was a vector that you had to detect to shift that, to correct that satellite location. So you get an image, and the image is made up of pixels. If you had the perfect model that would give you the closest pixel possible to the center of that dot, and you got that pixel, and then that pixel value converted that into coordinates, your error would have been let's say 0.02, right? This is for the perfect model. Just from rounding, the error would be 0.02. And here you can see the top 88 contestants all lie within that 0.02 range. So the score, you shouldn't pay too much attention to the score. You know, it doesn't mean that much if you can put it like that. Okay, so here I'll end up with this. This thing earned me a bronze medal on Kaggle, and I look at this. I was part of a big international team. I did a small part in this, but the idea here is to identify helmets and helmet collisions and to assign helmets to players. And I mean, I look at this, and to me, it's like sci-fi. You know, it's amazing. But there you can see the model detecting and marking collisions, and you know, and you can use that to detect injuries and stuff. So anyway, that's it. So I think with that I'm done. Any questions?
I've got a question.
Ewald, see you talking about drawing. Ewald, I must say this to you. I said to Ewald at some point, maybe I can present this talk, and he gave me a lot of tips. He really gave me some valuable tips. So thanks for that, Ewald. Of course, I haven't listened to any of that, but thanks. It was.
I think you did well.
It was nice. Okay, somebody, Tristan says, how expensive are those external processing GPUs? You can get GPUs for free, right? Or you can purchase GPUs from different clouds, such as Google or NVIDIA. Or you can go on Kaggle, and on Kaggle you get, I think it's 37 hours of GPU per week. So that you get for free. And in the team, the bit I didn't use GPU. I had to put everything together in the middle with these rotational matrices and linear algebra. I'm just a CPU guy. But my friends in my team, they would run out of GPU space every now and again, and they would share with one another and stuff like that. But yeah, you get 37 hours for free. What you pay for it, I don't know. I don't think it's what things have you used this knowledge for? It's a bit, I won't say disappointing. What can I say? It's a bit, you know, 6 months ago, I knew nothing about Python, for example. Now on my CV, I'll say I'm a senior Python. 6 months ago, I knew nothing about satellite photos. Now I've got a pretty, I pack a mean punch in terms of satellite photos and convolutional neural networks. So to some extent, you do it for yourself, right? You don't worry. Okay, I see. I'm terrible at both math and software. Where do I start? You know what? you know what's interesting about this is that this kind of thing rewards creativity. You know, Ezra, I look at the stuff you did, you know, and it's creative and it's problem solving and it's sort of going with the flow, you know, and finding solutions. That's really in demand, that kind of skill, you know. So now where do you start? Unfortunately, it's technical, so you probably need to either do some Python or be in a team where there's somebody that will do the Python. But you also don't need to know everything. Or a lot of different models. If you know one or two models and you really can apply them well, you can do well. You know, you can really do well and contribute a lot in a team. So in the typical team, there will be a diverse set of skills, and you will know one model and somebody else will know another model, and there's little overlap. And that's what makes the team great, is that you can combine these diverse models. So I hope. So what I'm trying to say to you is that really you should try it. Where you start, well, go over to Zindi and see if there's something that piques your interest. Maybe, I know a while ago I competed in a solar panel thing, for example. You know, find something that moves you, and then go for it. Zindi has some nice prices. I see 5,000. Money piques my interest. Oh, be careful, be careful. You know, my family is sort of vaguely aware that I build models for a living and for competition, and they're not sure where to separate the two. My parents, when I won a competition, you know, that caused a bit of a ripple in the family. MG's won a competition, and my parents like, oh my goodness, we thought he does this for a living. Do you get paid for this? You know, and this guy, this kaggle grandmaster I told you about, I've got a Zoom call with him. The first thing he ever told me, the first conversation we have, the first thing he says to me is, you know what? You can't make a living from this. I still don't know why, but that's my message too. You know, my family looks at it and they say, hey, look at this competition. It's got a $10,000 prize. And then when you zoom in, you know, it's $10,000 and 5,000 goes to the first guy. And if you compete in a team of 5 people, that means each guy gets 1,000. By that time, your wife's already spent $20,000. So, you know, you you must be careful when you judge the prizes. But anyway, Ewald says, I will have to look into this over the holidays. It's excellent. It's again, you have to commit, right? It's not something you're going to look in on a Friday and that's it. It's you must say, okay, I'm going to compete for the next 2 months. I'm going to put away 3 nights a week to compete. Then I think you really get benefit from it. But it's not, you know, it's almost like, let's say over the holidays you want to learn Python, for example. Do it with a competition. That would be nice. But it's not something you're going to do for 2 days and then you're tired of it. Then you stop. Then you don't get benefit from it. Well, yeah, I think that's it. Any more questions? Thanks, Alvin. I'll get back to Josh. Right?
I think Ezra will be taking over the outro.
Yeah, I'm doing the outro. I guess, thank you everybody for coming through. Let me just reiterate firstly, actually, we have got prizes, I think, so we should give a prize away. I saw Tristan was very, very active. So Tristan, if you could just send your email address, that should be good enough. We've got some, what is it that we've got, Joshua? MG mentioned it earlier on. Oh, there we go, email address. Let me just copy that. JetBrains, all right?
Yep.
Yeah, we've got some vouchers that you can use on JetBrains. I will get that through to you as soon as possible. Yes, interesting. We all learned quite a bit. I thought it was going to be a lot more math and a lot more things that I don't understand, but like it was easy to follow. And I'll keep the Zindi tab open for myself as well. Yeah, thanks a lot, MG. Two things as well. DevConf tickets, just reiterating. They're still on sale and there are still some early birds available. And then Geek of the Year is on the 8th of December. There'll be lots of prizes, quite a few prizes. It will be fun. I'm hoping that Robert will be the MC again. Always makes it so much fun with his Christmas hat, and we won't be able to see Robert today, but hopefully. Please try to come through. It's completely free. I think it will be via Zoom again. There we go. devconf.co.za. That's the link you go through to look at DevConf. Still sponsors, looking for a few more sponsors. So please reach out if your company might want to sponsor. And go ahead and buy tickets. It's going to be awesome. Yes, Eval, tickets available at devconf.co.za. All the information is over there as well. And finally, thank you to Interlet that kindly sponsors this Zoom meeting, hopefully in person soon, where there will be pizzas and beer and all sorts of other things to keep you entertained during these talks. Yeah, thanks everyone for coming through. And goodbye.